Welcome back to part 2 of our Godot Masterclass. In the last video, we learned how to build basic scenes and move a single node around. But what happens when your game grows? What happens when a player collects a coin and that coin needs to tell the UI to update the score? Or tell the audio player to play a chime and then tell the level manager to spawn a particle effect? If you hardcode all these references directly into the coin script, you're going to end up with a tightly tangled mess of spaghetti code. To build a scalable professional game, you need to understand Godot's trinity of communications: signals, groups, and autoloads. These three built-in tools reduce the need for tight coupling, making your code modular, reusable, and a breeze to maintain. So let's dive in. First up, signals. A signal is essentially a messaging mechanism. It's used to notify other parts of your game when something has occurred. It allows one node to communicate with another node without needing a direct reference to it. Godot comes packed with its built-in signals for almost every node example. Button nodes have pressed signal that emit when it's clicked. Area 2D nodes have body enters signals that emit when physics bodies enters the area. A timer has a timeout signal that emits when the timer is finished. You can easily find these available signals next to the inspector in the Signals tab when a node is selected. But the real power comes from defining your own custom signals. Using the signal keyword at the top of your script, you can define a custom signal like signal collected, and then when a specific condition is met, like the player entering a coin's collision area, you can emit it using code like this collected.emit. To actually react to this emitted event, the signal must be first connected to a function on another code. To do this visually in the editor, you must first select the node that's going to emit the signal, go to the Signals tab, choose the signal, and click Connect. Select the target node and specify the callback function. This decouples your logic perfectly. Instead of hard-coding references, you can let nodes announce that something happened and allow others to decide how to respond. Next, we have groups. A group is a label that can be assigned to one or more nodes. It allows you to organize nodes and call functions on multiple nodes at once without referencing them directly. You can assign a node to a group in the editor by selecting the node that you want to assign to a group, coming over here on the right to the Groups tab, pressing the Add a New Group button, typing in the name of the group, and then pressing OK. You'll know you assigned the node to a group when you see this square with a circle emblem in it. So why is this useful? Imagine you have a smart bomb item that damages every enemy on the screen. Instead of keeping a complicated array of every spawn monster, you can simply interact with all of them using a getTree call group method, as shown by the example currently on the screen. Using this example on the screen, we can see that it calls the group enemies, and then there's a line that says in the code that says take damage, and it's going to give them all 10 damage to every enemy in the group. Groups are incredibly useful for managing enemy units collectively, resetting traps at once, applying global effects like freezing all AI, or broadcasting events without signals. Finally, we need a way to manage data that persists when the scenes change. If you transition from level 1 to level 2, your player's current scene is destroyed and reloaded, meaning you lose their health and score. This is where autoloads come in. Sometimes they're called singletons. An autoload is a script that is loaded automatically when the game starts. It remains in memory for the entire duration of the game and is globally accessed. To set one up, go to Project, Project Settings, click on the Globals tab, find your script in the path option. In this case, we're going to add this global script. It's going to give it a name called global. Press add. If we look inside our global script, we'll see that you can declare variables like the score and create functions like this add score amount function, which adds a score plus the amount. Autoloads are ideal for storing player progress or global stats, managing audio across scenes, and tracking global states like level numbers. So here's the golden rule. Keep in mind that overusing autoloads can lead to tightly coupled code if not carefully designed. Limit their use to clearly global concerns. Let's look at this example. Say you're building a game where the player collects coins and each coin needs to update the score and inform the level manager that the coin was collected and of the score. Here's how you structure that cleanly. The coin emits a signal. The signal is then connected to the level manager. The level manager calls the global add score and triggers anything else you might have in the code. This setup allows you to separate coin logic from scorekeeping, level management, and things like sound. Each system does one thing and they communicate only through signals, groups, and autoloads. Pressing play on this example, we see when the player collects the coin, it prints out coin is collected and updates the score accordingly. Here's our level manager script so you can see that in action. When the coin is collected, the global add score function is called, then it prints whatever the global dot score is, in this case 10. If this architectural breakdown helped you, hit the like button and subscribe. In video 3, we're going to look at folder structure, version control to bulletproof our projects. See you there.